Microfluidic test structures are provided in a PowerPoint slide deck that is available on the website. Print out the test structures on a high temperature transparency using a solid ink printer. First, set a hot plate to 100 degrees Celsius. Next, place the pattern transparency on the hot plate. Heat the transparency for 4 minutes. This will allow the wax to reflow and will reduce roughness in the microfluidic channel. Place a couple of pieces of double-sided tape on the bottom of a plastic Petri dish. Cut out a test pattern from the heat-treated transparency and firmly attach it to the double-sided tape, pattern facing up. Next, pour the PDMS precursor into the Petri dish over the test pattern. You may tilt the Petri dish to help ensure that the PDMS precursor evenly coats the pattern. Lower the hot plate temperature to 90 degrees. The lower temperature will prevent the solid ink from reflowing while the PDMS cures. Place the Petri dish on the hot plate. The PDMS will take 15 to 20 minutes to cure. It is finished curing when it is solid and the surface loses its tackiness. After the PDMS has fully cured, remove it from the Petri dish. You will likely have to break the Petri dish. Carefully peel the transparency from the PDMS. Residual ink on the PDMS can be removed using isopropyl alcohol and a cotton swab. Remove the excess PDMS at the edges of the test pattern using a razor blade. A flat PDMS surface will make it easier to bond the PDMS to the glass slide. Next, locate the microfluidic inlet and outlet ports. These ports are indicated by the small circles on the test structures. You will use a luer stub adapter to punch holes through the PDMS. The metal tip of the stub should be filed or sanded to help prevent tearing of the PDMS. Now, create inlet and outlet ports by using the luer stub adapter to core holes all the way through the PDMS. Punch through the center of the circles. Using a piece of Scotch tape, remove debris from the pattern side of the PDMS. Place a glass jar on top of a table, upside down. The jar will serve as an insulating boundary between the corona and any metal on the table. Lay the PDMS test structures on top of the glass jar, pattern side up. Treat the surface of the PDMS with the corona. The corona discharge should be kept approximately 1 centimeter above the surface of the PDMS. The PDMS test structure is now ready for bonding to glass. Place a glass microscope slide on a table. Gently lay the PDMS on top of the glass slide, pattern side down. Use a Q-tip to remove any air or bubbles between the PDMS and the glass. Take care not to press down on the frosted white pattern, as this may collapse the microfluidic channels. Finally, place your completed microfluidic test chip on a hot plate at 90 degrees for 20 to 30 minutes. This will remove moisture from the interface and improve the bond between the PDMS and the glass. Your microfluidic chip is now ready for testing.